So in this video we will study one more example on the rate law, how to calculate the rate law from the experimental data. So this question is, find the rate law from the following data, where the NO is reacting with the oxygen and NO2 gas is forming, and these are the three experiment condition, and these are the initial reactant concentrations, and then rate is given. So we have to write the rate law for this reaction. So for the rate law of this reaction, I have already calculated here. We'll go to write. So for the reaction rate law, let's consider the experiment number 1 and 2, 1 and 3 first, where the first reactant, basically second reactant oxygen, is constant, concentration is constant, 0.0125, 0.0125, both places concentration constant for the oxygen, and concentration of NO is double from 1 to 3, and if we are increasing the concentration 2 times, and let's see what about the reaction rate. So 1.441 to 5.64, so this is almost 4 times, 14 times 4, 4.41 multiplied by 4, you will get this answer. So if you are increasing the concentration 2 times and rate is increasing 4 times, it means the order for the NO is second order. So here we have write first generalized rate law, concentration of each reactant with the coefficient exponent m and n. So first m we have calculated, this will be second order. Let's talk about the oxygen. So in the experiment number 2 and 3, first reactant NO is constant, concentration of this reactant is constant, and oxygen concentration is increasing 3 times from experiment number 3 to 2, and then rate is increases from here to here 27 times. Once you will divide 5.64 times 10 to the minus 2 divided by 1.52, you will calculate, it will come 27 times. So 3 times 27 times means the power is 3. So basically it's like a 3 multiplied by 3 multiplied by 3, then the rate will come 27 times. So order for the second reactant for oxygen will be third order. Now we can write the rate law. Rate law will be this one. So reaction is over, but question is over, but we have to write the K unit also, unit of K, and calculate the K also. So we can write K will be equal to rate. We can rearrange this equation. K will be equal to rate divided by one reactant with its order, second reactant with its order. We can choose any condition from here, any experimental condition. We choose second experimental condition. We can write the values of each rate and reactant. So rate will be 1.52. This is from second experiment with unit, and its concentration with units, oxygen concentration with units. Once you will open this one, so all the math once you will solve, you will end up 4.5 times 10 to the power 7. Let's talk about the molar units. So we can open like this one, molarity per second. So this is molarity per second. Molarity square, this is molarity square. Molarity cube, this is molarity cube. So molarity cube and molarity square will become molarity 5 raised power 5. So from here, one molarity will also be cancelled out, 1 and 1 cancel out, 1 over molarity raised power 4 second will remain. So we have to write the k in this form, that the 4.5 10 to the power 7 molarity inverse power minus inverse power 4 and second inverse. Then we can rewrite the rate law with the value of k with its units. So this is the another example how will you write the rate law and its unit. Let's calculate one more example. Example, finding reaction order from K. In this reaction, A and B, C is the product. The value of the rate constant K is equal to 4.2 times 10 to the power minus 4. Molarity inverse raised power 4, second inverse. What is the reaction order? So in this here you can see nothing, no value is given, only except K value. So but we can write a rate law. Rate law will be like a rate is equal to K reaction rate constant and A x raised power small m, B raised power small n. Now we are going to add only units. Rate is always molarity per second. K will also we have to replace with only units. A will be in the molarity raised power m, molarity for B raised power small n. When we multiply the power, basically they add up. So small n and m we can write small x. So molarity equal to rate molarity raised power x. Then we can rearrange this equation. These terms will be in the left side, this terms on the right side. So k will mx m raised power x will be equal to molarity per second. Now we can multiply, divide. So we will divide from here 1 over k, we will divide on both sides. So 1 over k means k, so both k will be cancelled out. Once you will multiply the k on this side, you will be basically moving k on the other side. Now we can add the units for the k, which is given in the question. Molarity raised power inverse raised minus 4 and second inverse. So here molarity minus 4, second minus 1. Once we will move this on the denominator to numerator place, this will become positive. Second cancel, molarity power will be add up. So this will be 1, this will be 4, total 5. So m raised power x will be equal to m power 5. So x will be 5. So total overall order of the reaction will be 5th order reaction. So this is the way we can calculate the order of reaction using units only. In the next video we will talk about the log and then integrated rate law.